Hello, my name is Svetkovich and my partner is Riley Balk, and our project is the shrinkage prediction of HDPE through material characterization, and our sponsor is Rig Pacific Company. Rig was experiencing variations in shrinkage in their injection molded crates that are made of variations of HDPE. They tasked us with creating a predictive shrinkage model for injection molded HDPE grades based on material properties. So we found through a lit review that shrinkage is primarily dependent on molecular weight, viscosity, and percent crystallinity. So using DSC, capillary rheometry, GPC, MFI, and pressure transducers, the difference between predicted and actual shrinkage can be quantified within 5%. After collecting data, we found that percent difference between DSC melting curves, capillary viscosity at a shear rate of 7,000 reciprocal seconds, and weight average molecular weight correlate when plotted as percent shrinkage after 24 hours as a function of the data collected, with linear trend lines for linear shrinkage and polynomial trend lines for transverse shrinkage. We picked which data to use based on R-squared values found from the trend lines. Anything closer to 1 had more accuracy, so we used anything with an R-squared value above 0.85 out of all of our data.
For the predictive shrinkage model, one equation was made for each shrinkage type, linear and transverse. The best fit trend line for the linear shrinkage graphs was in the form y equals mx plus b, which is a linear equation, and the best fit trend line for the transverse shrinkage graph was in the form of y equals ax squared plus bx plus c, which is a second order polynomial equation. All coefficients in these equations were found using the slopes of the graphs, leaving the y-intercept values as the unknowns that Excel Solver was used to estimate. Solver was used for crates 1 through 4 to estimate each unknown value in both the linear and transverse shrinkage directions. The estimated values were then plugged back into the predictive shrinkage equations and used to predict shrinkage in crate 5 and the regrind material. The model was then used to predict the values for crate 5 and the regrind to compare with their actual measured shrinkage values to calculate the relative error. All error values for both the linear and transverse shrinkage in both materials were under 5%, proving the model was successful in comparison to our hypothesis, meaning that we did successfully predict the shrinkage in HDPE crate grades.